Hi everybody, welcome to this next video. So in this one we're going to be looking at volume of 3D shapes. Could be in foundation, could be in higher, but I'm just going to go through the basic skills of how you find the volume of a shape and the variety of different shapes that we could be asked to find the volume of. So let's jump straight in. Let's look at this question first of all. It says find the volume of the following shapes, right? So the thing you need to remember, the key thing about finding the volume, so to find the volume of any shape, you will know that you need to find the area of the cross section. So you might have seen this where it says the area of the cross section and then times by the depth. Now what you need to understand is that the cross section is basically just the front face, okay? Or if the shape is standing the other way around, you could call it the top. So you could say the top face, the front face, and the depth can also be the height if the shape is looking the other way around. So if I quickly show you what I mean by that, so if you take a cylinder here, the front face you can't find. However, the top face here you could find. So that's what I mean by front or top. So in this case, the area of the cross section, the area of the front face, would be me finding the area of this. Now what a lot of you would do is you would just go 18 times by 15 and times by 12. And to do that in this question, you're absolutely right. You just multiply the three sides together to get the volume of the shape. However, when it comes to different shapes that aren't cubes or cuboids, you need to understand the process and what you're doing. So I'm not going to do that for this. I'm going to follow this process using this information for every single one of these questions. So find the area of the front face in this case, which is that purple bit I've highlighted, which means it's technically 18 wide by 12 high. So it is a rectangle I'm finding. So I'm doing 18, which is the width, times by 12, which is your height, and that gives you 216 centimeters squared. So that is the area of the front face. And then to finish it off, you then times that by your depth, which in this case is 15, and 216 times by 15 gives you 3,240, and now we're in centimeters cubed. Okay, so yes, you could just do 18 times 15 times 12 and you would get the same answer, but what you need to remember is that for different shapes you need to be able to find the front face and then times it by the depth. Okay, so that's your cubes or a cuboid. Obviously if it was a cube, it would basically end up having the same number that you're multiplying. With a cuboid, you're going to have different values. What happens then if you're asked to work backwards? And what I mean by working backwards is you're now being given the volume. So it's told me the volume here, and it's actually asking me to find a missing value. So in the previous example that we just did, we were given all three sides, and we needed to find the volume. In this example, we've only been given two sides, and I've been given the actual volume, so I need to work backwards. Well, what we can do is we can say the area of the front times by the depth is equal to the volume. Let's substitute in what we actually know. I can find the area of the front by doing 15 times by the height, and the height in this case is x, so times by x, and then times by the depth here, which is 20, and that is equal to 3,600. The question is therefore asking me to find x. Now, I can still do 15 times 20 here. Because that's all times, it doesn't matter what order I put that in. I could do 15 times x times 20, or I could do 20 times x times 15, or I could do 15 times 20 times x. It actually makes no difference which way around you do it. So if I work out 15 times 20, I know that that times that gives me 300. And what I'm trying to do is get x on its own. So I'm now saying x times by 300 is equal to 3,600. So in order now to get x on its own, I need to take this and take it over the other side. Because it's a times by 300 there, when I take it over this side, it becomes a divide by 300. So to find x, you are doing 3,600 divided by 300, and you get an answer of 12. So I'm now saying x is equal to 12. Let's check that. Okay, so let's make sure that what we've just done is actually correct. Well, area of the front would be 15 times x. We're saying x is 12. So 15 times by 12. So by doing 15 times 12, I get an answer of 180. And then your times in that, so that's your front. And then you times that by the depth, which is 20, and 180 times by 20 does indeed give you 3,600. So I know that my answer is correct. So that was me just checking my answer. This is your process of working backwards. So if you are already given the volume and you need to find the side, substitute your values in that you already know. So these are the values that I already know here, and then take them over and reverse it by working backwards. Okay, let's look at another example here. So you can see here in this example, we've actually now got a triangular prism. Okay, it tells me that it's a triangular prism, which means I need to go through the process as normal. Area of the front face. This is your cross section, as you'll hear it called, but also I'm calling it the front face. So the area of the front face this time is a triangle. Well, how do I find the area of a triangle? Base times height divided by 2 is the area of a triangle. So what I can say here is that the base is 15 times by the height. Now be very careful that the height you're looking for is this. It is the perpendicular height. It will not be this height. If you are given this height and not this height, you will need to use Pythagoras, reverse Pythagoras, c squared minus b squared to get your a squared there. But in this case, we are given the perpendicular height, so we don't need to worry about that. If you're not sure on how to do Pythagoras, if you watch my previous video that I've looked at explaining Pythagoras, it's worth just checking that out. So we're doing 15 times by 20 and then dividing that by 2. That's the area of the front, remember. Well, 15 times by 20 divided by 2 is 150. So I'm saying that the area of the front is 150 centimeters squared. Then you need to times that by the depth, and the depth here is 18. So 150 times by 18 gives you an answer of 2,700 centimeters cubed. So this is my volume. Remember, area of the front times by the depth. I could also do it a different way. Because this is actually technically half of a cuboid, you could effectively multiply all three sides together like we did in the first example, but then divide your answer by 2. So if I actually did 20 times by 15, which would be the area of the front if it was a square, which is 300, and then times that by 18, so 20 times 15 times by 18, which would be 5,400, and then divide that by 2 at the end, you would still get an answer of 2,700 centimeters cubed. Okay, so I would suggest if you stick to this concept, this idea, area of the front, this is a triangle, so you do base times height divided by 2, gives you that, times that by the depth afterwards. That's a better way of doing it than this. Okay, so the next bit we're going to look at is a cylinder. With a cylinder, we're following the same processes as we've done in the previous examples. So what we need to be looking at is finding the finding the area of the front face. So in this case, this is now your front face. Okay, so when you think about it being find the area of the front face and then times it by the depth or the height, in this case, the front face is actually the top now. So you've got to think to yourself, how do you find the area of a circle? And if you don't know, the area of a circle is pi times the radius squared. And remembering that the radius is half the diameter, it's halfway across the circle. So in this question, it tells you that the radius is 7 and that the height is 12. So area of the front face. So in this case, we're talking about the top face. So the top face is pi times 7 squared, which you can either use 49 pi if you're happy using things in terms of pi, Or if you work it out using your calculator, so you're doing pi times 49, which gives you 153.93791. I'm doing that to a few decimal places. That is now the area of the front. Okay, so the front slash top in this case. And remember, then you take that answer, so 153.93791, and you times that by the height or the depth in this case, which is 12, and we'd give our answer here being 1,847.25492, and this is obviously in centimetres cubed. This is a good point where we can actually now talk about rounding. If your answer said to 1 decimal place, here the 2 is your first decimal place, so you draw a line. How does that 5 affect that 2? Well, if it's 5 or above, it pushes that previous value up. So that becomes 1847, so 1,847.3 centimetres cubed. And that is the volume now of the cylinder. So just remember, with a cylinder, you're still following the same process. You're finding the area of the front face or the top face, whatever you want to call it. In this case, it is the top. And then you'll times it by the height. But just remember that in order to find the area of that, it is a circle. So it's pi times the radius squared. Okay. Last one we're going to go through here then is actually a slightly different shape. So hopefully you can identify that this front face now is a trapezium. So to find the area of a trapezium, there's 2 ways this is written. So you can either have it as half a plus b times by the height. Any of you that sit in the GCSE in 2022 in the summer, this is the formula that you get given on your exam sheet. Anybody else doing it after that date, then you won't have this given to you. The other way that I like to teach it is a plus b times by the height and all divided by 2. They are the same thing, because if you multiply something by half, it's the same as dividing by 2. Now the question is, what are a and b? A is this value here. What you're looking at is the 2 sides of a trapezium. So if I put these arrows on here, that tells me that this line and this line are parallel. A and B are basically just the 2 sides of a trapezium that are parallel. Because when you think about it, you've got that side and that side that are parallel. These 2 sides are not parallel, so it's the pair of parallel sides. So A and B are the 2 parallel sides. So in this case, what I would do is I'd substitute these values in by saying, I'm going to use this equation, by the way. 10, that's going to be my A. My B is going to be my 18. So plus 18. And the height, please remember that your height is your perpendicular height here. If you were given a slanted height, you would then need to reverse Pythagoras to find the perpendicular height. Just make sure it is that perpendicular height you're looking at. So that's all times by 4 and then divided by 2. Now you can break this down step by step if you want to. You could then say, right, well, that's 28 in the brackets times by 4 divided by 2. And if you work that out, you'll end up with an answer of 56 centimetres squared. Or you could work it out all in one go on your calculator, type it in. So that, remember, that is the area of the front. So the area of the front, and then now we need to times that by the depth. In this case, the depth is 20. So your depth is 20. So you're doing 56 times by 20, and you get an answer of 1,120 centimetres cubed, and that is your volume. Okay, so that's basically how we look at finding the volume of 3D shapes. Let's quickly recap here. You're looking in the first instance, what is a cube or a cuboid? You can effectively multiply all 3 sides together, but if you remember this, that is the area of the cross section, or as we've been calling it, the front or the top, and then you times it by the depth. because that will tell you then, depending on what shape it is, what formula to use. If you have to work backwards where you're given the volume and you're being asked to find a side, this is how we do it. And then here we've got the 3 different other shapes that you could have. So triangle, base times height divided by 2. Remember that we've got that there. That's the area of a triangle. If it's a cylinder, pi r squared, find the area of the top, then times it by the height. And if you were given something that looks like this is a trapezium at the front, a plus b times by the height divided by 2. Or you could just do a plus b, which in this case would have been 28, times by 4, and divide and times your answer by 0.5, which is the same as dividing by 2. Hope you found that useful, and I hope you find all the other videos useful as well to help you with your GCSE preparation. I will see you in the next video.